Hi, welcome to the last part of the SwiftUI for Beginners mini-series. In this video, we're going to create a timer app. By doing this, we'll practice creating more complex and dynamic interfaces. We will also get familiar with using observable objects as view models. Let's get started by opening Xcode and creating a new iOS or multi-platform app. The app's interface should depend on whether the timer is in its initial state, is running, or is paused. We'll often refer to these three different scenarios. Therefore, it's useful to create an enum representing those. To do this, let's create a new Swift file and name it helper. Inside this file, we declare an enum called timer mode with the cases running, paused, and initial. For keeping track of the current timer mode, we declare a corresponding state property inside our content view. We will use this state property to adapt the content view whenever the timer gets started, paused, or stopped. Now we're ready to start composing our interface depending on the current timer mode. We start by wrapping the Hello World text view into a navigation view. Then we wrap the text view into a VStack and append a simple navigation bar to it. Instead of Hello World, the text view should display the remaining time. For now, we use the temporary and static value 60 for representing that 60 seconds are left before the timer runs off. We highlight the text view by increasing its size. Next, we make sure to apply a top-only padding to it. Below our text view, we want to place a large play icon to start the timer. At this point, we could use image views with initializing custom icons like we did in the last video. But fortunately, there is a much easier way using system symbols. Apple provides us with a bunch of free icons we can use for creating our SwiftUI apps. We can initialize such an icon by initializing an image view while using the system argument. At this point, you are probably asking yourself how to know what system icons are available and how to find their names. Well, that's super easy. Just use the free Apple SF Symbols app. This macOS app provides you with a set of over 1,500 symbols you can use in your app. We provided a download link in the description of this video. Once you open SF Symbols, you can scroll through the symbols or search for a certain keyword to find the right symbols for your purpose. In our example, let's search for play. The app shows matching icons. We can use these by using their names as the image view's system name argument. For example, let's use the play.circle.fill system icon. However, the image view should only display the play icon when the timer is in its initial state. While the timer is running, we want to present a pause icon. Therefore, we change the system name parameter to conditionally show a different system icon depending on the timer mode state's value. Now, while the timer is running, the image view displays the pause icon of SF Symbols. Otherwise, it displays the play icon. When the timer is paused, we want to display a small rewind icon so that the user can reset the timer. While the timer is in its initial state, we want to allow the user to set the desired timer length. For this purpose, we're going to use a so-called picker view. A picker includes a list displayed as a wheel. The user can use this wheel for selecting a specific value. To use a picker for our timer app, we need to create a state property for keeping track of the current selection first. Next, we create the data set for our picker. In our case, we use an array holding the values 1 to 59 as integers. Now we can initialize a picker while binding it to the selected picker index state. We want no label for it, so just insert a text with an empty string. Inside the picker, we implement a for each loop that cycles through every object of our available minutes array. We use the loop's closure for creating one text view for every minute and assign it to an index. Now SwiftUI knows which index should be assigned to every integer in the available minutes array and updates the state depending on the current selection. Finally, we push everything to the top by using a spacer view. If you start a live preview, you can scroll through the picker. We'll use this functionality later on to set the timer length. Let's quickly check if our interface acts correctly by changing the timer mode state. When we change the timer mode to running, the picker disappears and the play icon should get replaced with a pause button. When we change it to pause, the rewind icon shows up. Great. We are finished with implementing the interface for our timer app. Let's get started with actually implementing the timer functionality. You already learned what state and binding are used for. For implementing our timer functionality, we'll use a so-called observable object. Observable objects are similar to state properties but with some important differences. Rather than a property wrapper that gets assigned to variables, observable object is a protocol classes can conform to. Of course, these classes can contain data. For example, a string assigned to a variable. We can bind one or multiple views to the observable object. In other words, we can make these views observe the observable object. The observing views can access and manipulate the data inside the observable object. When the data of the observable object changes, all observing views get automatically refreshed. This is very similar to when the data assigned to a state property changes. Don't worry, I'm pretty sure you will grasp this concept by applying it in practice. Let's implement an observable object by creating a new Swift file and calling it Timer Manager. Make sure you import the SwiftUI framework. Next, insert a class called Timer Manager that conforms to the observable object protocol. Our timer manager should keep track of whether the timer is running paused or in its initial state. Therefore, declare a variable called timer mode. We want to initialize an actual timer manager instance right at the launch of our timer app. To do this, let's go to the timer app file and declare a timer manager instance as an observed object. We can now pass this instance to our content view. Next, we want the views in our content view to refer to the timer manager's timer mode property instead of the content view state. Because we won't need it anymore, we can delete the timer mode state property. Next, our timer manager class needs another property for keeping tracks of the seconds remaining. We want the text view in our content view to refer to that value instead of using the static one. Now it's time to implement the timer logic. Implementing a timer in Swift is really easy. We just need to add a Swift timer instance to our timer manager class. Next, we add a function called start to our class that actually triggers the timer. We will execute this function when the user taps on the play icon. When the function gets called, we change the timer mode to running. Then we tell our timer to decrease the seconds left every second until it hits 0. Note that there are more accurate ways to implement timers in Swift. For the sake of simplicity, however, we are using this approach. As said, we want this function to be called when we tap on the play icon. We could do this by wrapping the corresponding image view into a button. But there's an alternative, more efficient way to do this. We can simply add a tap gesture to our image view. This gesture notices when the user touches the image view. Let's check if our timer works by running our app in live mode and tapping on the play icon. However, nothing happens yet. This is because until now, changes in the seconds left property don't cause the observing content view to refresh itself. We need to tell SwiftUI that all observing views should get updated whenever the seconds left is decreasing. To do this, we use the published property wrapper. Every time the seconds left gets updated, now the content view will be refreshed with eventually showing us the remaining time. Let's use the published property wrapper for the timer mode so that our content view reverts to its initial look when the seconds left are hitting 0. If we run our app now, and tap on the play icon, our timer starts decreasing every second. When it hits 0, the timer reverts to its initial look. Okay, we already have a function for starting the timer, but we still need one for pausing and resetting it. Therefore, let's add these two functions to our timer manager class. You maybe notice that the code inside the reset function is the same that we execute in our start function when the seconds left hit 0. To refactor our code, we simply call the reset function from our start function. In our content view, we want to call the pause function when the user taps on the pause icon. To achieve this, we update our tap gesture modifier as follows. We call the reset function by appending the corresponding tap gesture to the image view that shows the rewind symbol. Great. If we run our app now, we are able to pause and reset our timer. We're already able to start and pause and stop our timer. However, we can't set the timer length by using the picker yet. To store the chosen time persistently, we're going to use the so-called user defaults. User defaults can be used to store small chunks of data such as our timer length setting. For this purpose, we add a function called setTimerLength to our timer manager. The function should accept the desired time length as an integer. We can access the user defaults like this. The structure of the user defaults is very similar to a dictionary. We can store pieces of data under a certain key and retrieve it again by using the specified key. We call the setTimerLength function when we want to store the given minutes under a key we call timer length. Finally, we set the publish seconds left property to this value when the function gets called. The seconds left property is still 60 when the timer manager gets initialized. Instead, we want to retrieve the stored value from the specified timer length key. We want to retrieve the timer length from the user defaults inside our reset function as well. We want to call the setTheTimerLength function whenever the user is starting the timer. Therefore, we call the setTimerLength function from the content view's play and pause image view, but only when the timer mode is initial. For the minutes parameter, we use the selected minutes from our picker. If we run our app now, we're able to set the desired timer length by using the picker. However, when selecting, for instance, 12 minutes, our app shows us the plain seconds left. Instead, we want to display a timestamp for readability purposes. To achieve this, just add this function to your helper.swift file. In our content view, we can now use this function to convert the seconds left integer into a corresponding timestamp string. That's it. We are finished with creating our timer app. We learned how to create more complex and dynamic interfaces with SwiftUI. We also explored observable objects and how we can use them as our views model. Additionally, we learned how we can use Swift timers and how to store small chunks of data persistently by using the user defaults. You can find the whole source code of the app by clicking the link we provided in the video's description. That's it. We hope you enjoyed our introductory SwiftUI course. You should now be able to create your own small iOS apps using SwiftUI. You can find many more tutorials on our website. I'm sure there is something for you. If you have any questions, just leave a comment or send us an email to contact@blackbirds.com. If you want to dive deeper into SwiftUI, check out our interactive Mastering SwiftUI book. This interactive book is the perfect opportunity to expand your knowledge about SwiftUI. You will learn how to build more complex app interfaces and functionalities. For example, an app that uses the Flickr API to display photos nearby the user's location, or an app that keeps you up to date with the current stock price. While doing this, we practice our skills in building more complex interfaces. We'll also learn how to extend the functionality of our apps. For example, you'll learn how to use core data to save data persistently or core image to edit and customize taken photos. Creating a real-time chat messenger using the Firebase platform is also part of the interactive book. Last but not least, you'll learn how to create widgets for your app using SwiftUI. As a graduate of this mini course, you will also receive 25% off the Interactive Mastering SwiftUI book. For more information, click on the link in the description. We hope to hear from you and thank you again for watching our videos.